Hello, everybody. Welcome to another Sparking Interest podcast from the ASFP here in our what has been rather warm corner of the posh part of Coventry, as somebody called it, who came to see us the other day. Today we're going to be talking about the interesting subject matter of buildings that move, because of course buildings do move, and in the world of passive fire protection we have to accommodate that movement. So I'm not saying we're susceptible to the high risk of earthquakes, although there was one in Tipton about 10 years ago that caused about £3.99 worth of damage. I think they're over it now. But occasionally we do get the odd rumble, unlike some other parts of the world, which we'll talk about through the process of this conversation. We're talking about buildings that move for all the reasons that buildings do move, and we're going to be enlightened on that fact by Hannah Eyres, who is the technical manager for Firestopping of Tremco. Welcome to the ASFP, Hannah.
Thank you.
How are you finding our broom cupboard?
It's beautiful.
Without Gordon the gopher, for those who are old enough. We can't say the other name.
A little bit gutted
anymore.
that Gordon's not here.
Gordon's not here. We couldn't afford him. His agent wants too much money for him. So buildings move.
Apparently.
They do.
Shocking.
This is what I've been told. Well, actually, this is what I experienced. In my previous life, I worked for a company where we were in places far, far away. And one of those was Taiwan. And
nice.
We went to... So Taiwan had a testing institute, which was associated to their university, for earthquakes, because they have quite a few earthquakes in that part of the world, and they test the movement of construction joints and foundations and all that sort of stuff.
Okay.
And they had these big vibration sort of pads and various other things, because apparently more people die as a result of an earthquake in fire than they do from what people typically think they would be sort of succumb to.
Interesting.
So they tested a lot of these sort of flexible joints, flexible partitions, umbilicals for things like gas and electric, because earthquakes cause fire, because gas mains rupture and things like that. The irony was, when I went the first time, probably about 10 years ago, they'd just built a new research centre next to the old one, which is about 100 years old. And just before I got there, they had a very big earthquake, and they'd all had to move out of the new research centre back into the old one. Because the new research centre had got a huge, great big crack down the front of it, and the old one, built about 100 years ago, was perfectly okay.
Typical.
So I did say, I said you probably want to relook at your own homework if that's what's happened. So we know the dangers, but in terms of that, but of course we're talking about something slightly different. We're talking about building movement that's caused by us people.
Yeah, a whole host of different
things
reasons
that go in it. So I did get my trusty green highlighter pen out, and I did mark up dynamic loads, the weight of potentially thousands of people entering a given area within a building.
I quite like analogies because I'm only a simple human being, and I always think of a football stadium.
Yeah.
So most of the time during the week it's nice and empty.
Yeah.
But then 3:00 on a Saturday afternoon, you get thousands of people descend upon the stadium.
Yes.
Unfortunately, they do weigh a bit.
Yes.
Thousands of people.
So
there's...
Being a Villa fan, I can confirm some Villa fans are quite heavy.
And all the food they bring with them and the
course.
drink. Yeah.
Yeah.
And then, post-game, a couple of hours later, depending on how well Villa have done or not done,
Yes.
depends how quickly they leave.
Yes.
And so again, that load is then removed.
Yes.
Over a relatively short space of time.
And I suppose, some of these stadium hold, sections of them hold tens of thousands of people.
Yeah.
And that's quite a
Quite a load.
significant differentiation between nobody being on it and people, amount of people being on it. So that was dynamic. I think we've got the airport arrivals when it's busy, etc. And then we've got static, possessions, fitments.
In the UK, we love a good statue, don't we? A nice marble
I
statue.
do. Well, funnily enough, we were talking about having one outside of one of our notable members of the team, who will remain nameless. And when he said he wanted it in bronze, I said maybe fiberglass sprayed gold would be more affordable. And then we've got wind loads. So interestingly, environmental load, things like water and wind, plays quite a significant part in structural design,
Yeah,
engineering considerations.
Especially when they're tall buildings, very tall buildings.
Yes. I do remember it being years ago. I went up one of the North Tower of the Twin Towers in New York, and it was a pretty hairy day, weather-wise, and you could really feel that thing moving about. Yeah, on the top of the viewing platform.
Oh,
it was
God.
moving quite significantly. And then fire loads, deformation and twisting of substrates due to, well, it's obviously down to heat and deflection, etc. So at Tremco, part of your group is Nullifier, and you've done some testing recently, which attempts has succeeded in attempting to replicate movement on penetrations through a fire resistant partition.
So it's really difficult at the minute for manufacturers to do testing on movement and services, movement and fire, because the penetration standard doesn't really consider movement currently.
No.
In its existing form
I
anyway.
did make a note. UK guidance documents such as Approved Document B offer no guidance beyond stating words like appropriate and suitable. Now that's interesting because I'm a big advocate of this debate around subjectivity.
Yeah.
So you'll see if you're an avid follower of our world on LinkedIn, there are some people that maybe sort of preach moral codes maybe more than others.
Yep.
But the problem with morality is it's subjective.
Yeah.
What you think is something that's acceptable, I might not, and vice versa. So the problem with that is appropriate is subjective. Somebody might think that one level of performance is appropriate over somebody else that may think, well, actually that's not good enough.
Yeah, not enough or
suitable.
Too much. Agreed. Yeah.
Suitable. How do we define that? So I think ADB clearly needs some work, and of course it is coming up. It is currently under review, and of course 476, the transition of that out of it, and the 1600 EN series going in will,
I think, create
some debate.
ADB, it's interesting because it recommends 40 millimeter deflection. So there's a lot of people out there in the industry that go, oh my God, 40 mil, we have to account for that. But if you read the entirety of that sort of area, that paragraph of ADB, it highlights that that's 40 mil in the middle between two supporting structures. And that's unless they can identify the actual load or deflection, and you can utilize tools like heat maps to identify the specific amount of deflection, which we always recommend you do because you get a more realistic number rather than a 40 mil. That's quite a lot for fire stopping products, certainly.
It is. Well, I think if you're doing a fire test, if you have a gap greater than 10 millimeters open, that forms part of the failure criteria when they stop the test.
Yeah.
So that's 4 times a failure criteria for a current fire test.
Yeah.
For lay people, because we always try and put these little podcasts together for people that we'd never consider them experts. And that's why I think I'm probably one of the best people to present this, because if you talk to anyone in our industry, Mike Ward's the greatest lay person in our industry that we know. So we're talking about building movement, and we're talking about the gaps that can be created between floor levels and partitions, vertical partitions that sit within those individual floor levels, and services running through them. So your typical pipes, cable trays, all that sort of stuff. So there's a challenge in creating flexible, fire-rated ceiling, let's call it that word, solutions, where you've got a floor and a wall, and we'll try and get some pictures for this, everybody, so you can actually see this. We'll get some dropped in, because my hands trying to describe this is probably not the best.
I do the same, and you end up doing some very odd hand gestures.
Indeed. Normally a waiter comes over when I do this and says, do you want the bill? Now I'm just trying to explain this. So we're talking about this gap here between the floor and this top of this partition. Compartment wall, and it's that gap. And people walking up and down on the floor above it, makes it move, or people walking on the floor that the wall is connected to
move it down.
Moves it down.
So the way we see it, there's two types of movement in buildings, exactly as you've just said. So I'm going to use deflection for that. So wall deflection, soffit deflection. But then there's the lesser considered one, which is service movement. So that's how we term it, which is where your services go through a compartment wall, but they're attached to the soffit. So as the soffit, as you've just said, goes down, naturally those services will also go down.
Yes.
And if your services are going through a seal that can't cope with that amount of movement, you're going to get rips in the bat or the mastic, or you're going to get cable pinching, or a whole host of different things happen. So we talk about two different types that are very closely linked, obviously. But yeah, the second one poses more of a difficult issue for the industry than the first. There are, existing solutions out there. Deflection, lots of sealants, lots of mineral wool type solutions. And within the linear gap standard, it does have Annex B, which, does account for movement, and you can utilize that within the test. But coming back to the service penetration test, 1366 part 3, there's just no movement considered there whatsoever.
No. Does it go back to those words of things like appropriate and suitable?
It does indeed, yeah.
Reasonable.
Reasonable, my
reasonable.
favourite word.
You see, I like reasonable.
I'm constantly told I'm unreasonable.
Really? Join the club.
Just by account.
It's better to be infamous than famous, by the way, if ever that one crops up. So in terms of, I mean, the scenario you just mentioned, I think if you're a designer or an engineer, is probably something that is not that apparent to you, because you can have services that can be affected by movement a long way away from where there's a net result of that movement. Yeah,
certainly.
And you could be talking meters and meters and meters. It could be 20, 30, 40 meters away.
Yep.
And it's similar to the sort of, we're working on the ASFP is working on some stuff with one of our fellow bodies, the Modular and Portable Building Association.
Know them very well.
About the challenges of voids being created, of joining boxes and sections of.
You end up with the nice matrices, don't you?
Yeah.
Gaps.
And how do you and the issue can be all the way over there, and yet the resulting effect can be over here, because you can have a fire in a void and you wouldn't even be aware of it.
Absolutely.
And how does that affect the systems that are within that void?
Scary thought, isn't it?
It is.
If the smoke emanating from here, but actually your fire source is here,
what
do the fire
30 meters away?
Yeah.
Well, they assume it was at the location of where the smoke is, but of course, very often it's not. So that's a consideration I think that designers need to look at, and I don't think it's that. I think this whole conversation around movement, whether it's the movement of services or the relationship between a vertical partition and a finished floor, floor level, is that something you as an organisation have come across quite a lot, that there's actually quite a significant level of ignorance? And I don't mean ignorance in the defamatory term. What I mean is that there's a lack of understanding of the consideration of it as a risk. Yeah, so that's a really interesting question. I think out there in the world, in terms of realistic, how many times realistically do we come across on our site visits fire stopping seals that are actually damaged due to excessive movement? I think it's an interesting thought, because I'm not particularly aware. I don't know how much work you do as an organisation in terms of getting out there and sort of presenting this as a potential risk or issue. And it does go back to this, the SCEB, skills, knowledge, experience, behaviours. And certainly within the design and engineering community, it'd be interesting to understand how many are actually aware of this particular challenge, because buildings have got more complex by virtue of the M&E. Yeah. Because technology has made them more complicated by virtue of the M&E. Technology creates more wires, cables, boxes, things that go ping and have flashing lights on them. Whereas, traditionally, even if you were building a building in the 1970s, it was the main structure the external facade, the internal fit out, you had gas, you had electric,
job done,
and you
kind
had
of thing.
telephone lines.
Yeah.
And it was sort of done. But now, and I think probably the only exception to that would be something like a hospital, where traditionally there was always more, compressed air, gas, various other things going around the place that required that sort of more detailed thought.
Yeah.
So have your findings, has the work you've done as an organisation, have you found that there's quite a significant level of lack of understanding of this particular challenge?
Yeah, certainly. So my team, we talk to customers on a daily basis, and I mean, you do get some really sensible requests, but you also get some very silly ones which highlight that people have an awareness but not really a true understanding.
Yeah.
So one of my favourites, I've said this many times, is we've got a 25 millimetre gap and we've got 25 millimetres of movement. Physics doesn't work that way. There's no products out there that will sort of deflect down to 0 and then back
it's
up
plus
to 25.
or minus 25, isn't it, from the centre
and then that
point.
Brings another element of understanding in as well. So okay, it extends, so actually they want a gap from 25 to 50. So yeah, you do get some very, very weird requests. My building's going to move by 200 millimetres. Wow.
200?
Yeah, honestly, that's a slinky. Surely it's just doing this. Sorry.
Possibly. Yeah, well, a bit like the microphone.
Yeah.
But they're fine. We've tested those for,
They can cope with movement.
They can cope with movement. So how do you, how have you been looking to get the message out there that this has to be has to be a significant consideration? Because, I was just reading on the testing that you'd done, and you'd done that with fellow ASFP members, Warrington.
Yeah.
And you'd built a rig that replicated the movement during the fire test. So
we sat down with Warrington and said, okay, guys, we'd really like to be able to prove a real world instance where, your services are subjected to movement and then they're burnt.
Yeah.
So we thought, okay, can we move the services during the fire? Bit dangerous. Pretty dangerous. So what they did was they built the rig and they put it on hydraulics. So they then held the services in place, but moved the wall up and down. So we affectionately call it the bouncy wall test. So you bounce the wall by 30 millimetres multiple times over a set period of time, and then put that rig onto the furnace and burn it. So you can demonstrate that seal in isolation has experienced significant movement.
Under a fire load.
And then been subjected to a significant fire load. Well, the standard fire load, sorry.
Okay, so you bounced it first, pre-burn,
and then put it onto the furnace.
No, I can understand that, because coming from my background in operable fire and smoke curtains, the standard BS8524 for curtains, which is still the most represents the product in its final installed solution. There was a reason why 8524 was created, but we won't go into that. But part of that test criteria, you had to do so many cycles pre-burn to prove that it was an operable curtain before they turned the furnace on.
Which makes sense, doesn't it?
Because, as you say, in 476, there was no allowance for that. It just said, that means you could have helped it on its performance journey by sticking some fire-resistant mastic up the guides.
You could have bounced it 1 mil versus...
Yeah. But you had to open and close it. So what you're showing is that it's a completely operable curtain. So actually, in terms of the theory behind it, by flexing the wall with the penetrations in it, what you're doing is very quite similar in a way to what the fire curtain industry do, which is that you're replicating if you're under 25, you call it a lived experience, because they all call them that, apparently.
I wish I was under 25.
Yeah, really, me too. Well, double it and add a bit, but never mind. If I was talking to my kids if I was having an argument with my kids about something, they'd go, well, it's a lived experience.
I'll remember that one.
Yeah, it's
a lived experience.
It's a lived experience. So what that wall has done is had a lived experience before you then subject it to the heat curve or the fire load.
Exactly.
Because, and I think this is important within fire testing, one of the challenges of fire testing, without doing things like operating a curtain or doing the flexing of the bouncy wall test, is that you're assuming that the only time a fire will happen is the day that building gets handed over.
Absolutely, when everything's perfect and pristine and no one's touched it, and your BT man's not come back and added another cable to make something else go ping, as you said earlier.
Are they still called BT?
I don't know, sorry. That's how old I am.
I was just...
over 20,
got
over
yellow
25.
Vans yellow vans with a bird on the side of it still, have they? Sitting on a telephone line. So... No, you're right. I mean, and that's the point, is that the safest a building will ever be, apparently, because some might argue the case, is the day it gets handed over.
Agreed, yeah.
So here's a question then. Just taking it from the point of view of the designer and the specifier, let's just go through the whole design construction chain. When we get to the point of, and we can come back to it, when we get to the point of inspection, Institute of Fire Safety Managers, local authorities, building control, members of CABE, so approved inspectors, that community of risk assessors, let's call them, do they know what they're looking for?
Not when it comes to movement.
And so this is my point.
Yeah.
Do they know what they're looking for in terms of the risk that movement has on possible, and let's say the building's 5 or 10 years old, so it's lived a bit of a life.
Yeah.
And it's starting to, it's showing its life on its face, if that makes sense. And they inspect something, and there has been some movement, and there has been some degradation because of that movement. Do they know what they're looking at there, and do they know what that's a result of? Because you say they might call a local company and say, "Can you make good that?"
Yeah, I think that's exactly what they would do, is go something.
But it's only going to happen again because
Exactly.
actually maybe the solution, that particular specification of solution,
it's
isn't
putting
suitable
plaster over something that they've not really understood what's caused it, what's
Yes.
caused that wound to open up. Yeah,
or batten mastic if
literally.
plasters. I'm not sure.
Wouldn't recommend it.
Don't
Batten
use
mastic.
plasters, anybody. It's not doesn't work. So, and that's sort of a question, because if there is a level of ignorance at design, not understanding the potential problem, is there a level of ignorance? And I don't like to use the word ignorant because it sounds like it's premeditated, stupidity or something. But ignorance is a term of not knowing, isn't it?
Yeah,
so,
absolutely.
So, is there that level of ignorance that means actually any solution to a problem that's caused by this is only going to be, as you say, a sticking plaster, and it will just happen again?
Yeah, I think really that comes down to the experience of the individuals. They do the maintenance, they look at it and go, okay, we need someone to come and make good. But then the individuals who go along to make that seal good, do they recognise that that's what's caused the issue, and then talk to the manufacturers? I think that's the weak link there, is people's experience at all levels. So, we talked a lot earlier about architects and designers, but you're right, the maintenance people, the installers, and, what's their understanding, and do they know what to do in those situations? It's a very good point. Probably not an awful lot.
No, and I would imagine people within the facilities management
Certainly not.
community maybe wouldn't. And of course, it's hard. What they call it hardcore, softcore. Softcore's people. Yeah. Security guards, cleaners, cooks. Hardcore is the building structure.
Yeah.
And there's two sort of areas to it. So I think that creates a challenge in itself, doesn't it? Because of course, there's a position of understanding at the point of design and engineering of it.
Yeah.
Then we get into the world. This is where it's going to get messy, by the way. Then we get into the world of procurement and construction, and the world of equal and or approved.
Oof.
Show me a QS that's made a purchase decision change without it being a commercial decision.
Yeah,
sorry QSs,
exactly.
But come to that. We can have that debate when you come to the ASFP. And also, obviously, this, we're moving away from design and build in the traditional sense, and design and build now is gateway 2, gateway 3, as in you can't build until you've designed. And I know there's a lot of noise around that at the moment, slowing things up, but organisations like us, our responsibility is to support the transition, not throw the baby out with the bathwater. Because what we can't do, and what probably creates a lot of problems in your space, is back to this design as you build. We cannot go back to that. It's an absolute,
oh my God,
we
nightmare.
I'm not saying the current solution is perfect, and clearly it's not, but we can't go back to that.
It's an improvement for sure.
Yeah, it's just, I think the trouble is these things get launched without being...
They get launched at a high level, don't they?
Resourced. Yeah.
Yeah.
Yes.
Where at the top level they go, oh yeah, that's a really good idea.
Yes.
But then they don't think about the layers beneath it and what's actually required and the time it takes. And like you've just said, the resource, oh my word.
Yeah, they don't. And it's similar to the whole competency thing as well, is that, certain things, competency ideas get launched at high level by government because it makes the government minister concern popular. But actually how it cascades down to the people that work on construction sites in our space, in our world, is very different, and a lot of the time it doesn't. Yeah,
it's not always practical, is it?
Get that far down. A lot of this needs to be looked at actually, interestingly, bottom up. Yeah. So from that point of view, procurement, specification, design, then build. How's one of the mantras of our world at the moment is this early engagement. And you may have heard me talking about my personal journey or goal, because we're all on journeys, by the way, as well. Anyone that's been
is that another under 25?
Well, anyone that comes out of Love Island this summer will have been on a journey.
Oh dear.
Yeah, they haven't. They've just been in a villa for 3 weeks. Is to turn the perception of the passive fire industry from a trade into a profession.
Yeah.
And the reason why I want to do that, and the reason why we're moving towards a bigger step in that direction quite soon, is the perception of the people that work in that space. So if you go into you get invited into a porter cabin, there's the client, the architect. Now the architect's seen as a professional, because they have a degree and they feed off CPD points thereafter. You may have an engineer, RICS or CABE or somebody. You've got other people around that table that would all be considered professionals. Yeah. And we trust those professionals like doctors or dentists or lawyers or judges and things. We trust them because the perception of them is they're professional. And they've gone on some academic or professional journey that continues to warrant that ability to say that. And then you get some very skilled, knowledgeable person going for a meeting who spent, has got invested an awful lot of their time and effort into the passive fire sector. Yeah. Who's in front of these professionals, and their perception of them is they're a tradesperson.
Yeah, which is really sad, isn't it? Because those people are experts in their own field.
Absolutely.
They, like you've just said, put so much time and effort into their CPDs, into their making sure that they're doing the right thing in the right way. Yeah. And it's one of those things that I think doesn't get enough credit from the professionals, for sure.
So that's why we want to move in that direction, and we will move in that direction. But that's a different conversation for a different day. But when they're in that environment, and I'm assuming some of these organisations have got enough skills, knowledge and experience to have those conversations around movement, around deflection, how it needs to be done. And then all of a sudden it dawns on the client or it dawns on the principal contractor that it's now going to cost 20% more.
Yes, which obviously they don't like hearing,
because the architect didn't understand and therefore didn't accommodate that in the design. Yeah. Is that an area? Is that a sort of? Is that something you've experienced and you've had to have those retrospective conversations?
It's more the other way around. Like I was saying earlier, they get a number, and it's not a very realistic number, in my opinion, because it's subjective, as we said earlier. And it's almost like you and the installers have to say, hang on a second, are you sure your building's going to move by that much? Are there other ways you could look to quantify that number? So not normally that it's not considered. At the minute it's considered. It's a big hot topic, forgive the pun. Okay. But it's normally the other way around. They've considered it but allowed for too much, like an unrealistic amount of movement. So yeah, it's interesting. It's the other way around that's the problem.
So are they giving you sort of deflection numbers that would actually mean if it did move around that much, the structural integrity of the building itself would degrade.
In my opinion,
it would probably just start
absolutely.
to fall apart.
It's just, as I said earlier, your building should be doing this, the amount of movement that they say it's going to cope with. And also concrete structures. They move an awful lot, and you get quoted some insane numbers, and you think, take a step back, please. A little bit of common sense. So, yeah, it's interesting. And then how do we educate people as to realistic? I mean, we can only use the tools that we've got to hand. So, utilise you guys because you've got a really good reach out there. We do CPDs, as, many other members do in the ASFP. We write white papers, documents. We've got a great marketing team who, put things out on LinkedIn and get our experts in research and development to write things in such a way that, the layman, you and me, can understand. It's just about utilising all the tools we have to hand, and how we can reach those people. So, do we go to the journals, the architectural journals, the engineering journals, things like that? It's just trying to reach those people through whatever means necessary.
Yeah, it's interesting, isn't it? Going back to that sort of, everyone sat around the table for that first meeting and the perception. And I've had it quoted to me, well, they don't want to listen to us because they think we're just trying to sell them something.
We're trying to upsell, yeah.
We're trying to upsell. And I did have a conversation with an architect once saying, well, so you're doing this for free then? And they said, no, we're not doing it for free.
Out of the goodness of their heart, yeah.
Yeah, I said, so you're a commercial operation then, as in you seek out work. Yes, of course we are. I went, well, so what's the difference between you and somebody that manufactures and sells products, or somebody that sells a provision of service, like a specialised installer, Firestopper?
Yeah.
There is no, because everybody's there.
At the end of the day, we're not there out of the goodness of our heart. We're not there even to sell fire stopping or to design buildings. We're there to make money so we can pay our bills.
Yeah.
At the core of it all, sadly, that is.
But I think everybody in the room is the same. That's sort of because there's this perception that you shouldn't believe a manufacturer of passive fire products, or you shouldn't believe an installer of passive fire systems or products because they're a commercial business, and we shouldn't listen to them because they're just going to tell us something that makes them money.
Yeah.
But yet your architect, your structural engineer, your fire engineer, your principal contractor, anyone that would be perceived as a profession, are all
making money out of it.
So I think we need, my point I'm trying to make with this is we need to level the playing field and stop pretending that somebody that works, in a perceived trade is any less different to somebody that is perceived as a professional.
Absolutely.
Now,
I agree with that.
There might have been some differences a few years ago, but with the whole competency framework that's now been created within ICSG and the pathway, and how the cert bodies are now coming on board with improving things like the installer schemes, you could say that anyone that works within manufacturing products or installing products within passive fire, there is effectively a professional journey that they can go on to professionalise themselves. Okay, they may not have come out of Oxford or Cambridge or Bristol or Birmingham with a degree in philosophy, but what we can say is the moment they enter the passive fire world, we can take them on a journey of professionalisation. Yeah. So why shouldn't they be engaged with at the same level?
Absolutely, they're experts in their own field.
Because you have that lived experience of your particular part of it.
Some people in this industry that have less time for killing someone, don't you? They've spent 20 plus years on the tools, talking to main contractors. The wealth of experience these individuals have is incredible, and for it to almost be dismissed is very, very, very unfair.
It is unfair, and it's also unsafe. So in terms of going back to movement of buildings, and you saying they're almost they're over-egging it, they're over-engineering the idea of movement. Is that different depending on what the building's made from? So you say, concrete hardly moves. People think, well, concrete is absolutely, fire resistant. Of course it isn't, because it heats up and the rebar blows. If you look at the Luton Airport car park fire, that just showed actually how concrete behaves in significant fire conditions. Steel frame buildings, lightweight, significantly popular, we're now moving into modern methods of construction, panelisation, timber,
a whole other kettle of fish, isn't
engineered, renewables, and that poses a whole risk in itself in terms of, concrete doesn't burn, neither does steel. They react differently, but of course, timber can, or smoulder. If you've ever seen one of the questions on the IFE Level 3 exam, is that it's depending on the structure, what effectively it's made from. Does that have an impact on this level of movement that has to be considered?
Certainly. So, you mentioned modern methods of construction. So if you take wood, timber, CLT, for example, that crops up more and more nowadays.
Mm-hmm.
And we all know that wood swells, it shrinks depending on the humidity levels, the heat. So that naturally is going to have a much wider, more frequent degree of movement than, for example, concrete, which, once it's settled in, once it's embedded, moves very, very little. Steel, moves more than concrete, but not a whole host. And it's obviously supported by insulation and plasterboard. So, yeah, it's an interesting consideration. But for me, it's more the modern methods of construction that pose a bigger risk to those types of movements and quantities of movement. Yeah, and there's a certain amount to be said for over-egging the amount, that's a safety comfort level.
Yeah.
But if that's not a number that can be achieved by anything we have currently in the industry, then it becomes a problem. There's that degree of safety is a good thing, but when it becomes beyond the reach of existing solutions, until we've got some super smart people in an R&D department somewhere that come up with those solutions, you're limited by what we've got in the existing market, aren't you?
Yeah. No, I think, and like always, technology always outpaces code and legislation and standards.
Absolutely, yeah.
If you look at ADB, you could probably use it as much to build something from 1930s sort of standards and specifications as you could now, because it's so top line, it's so generic.
It's a really good set of guidance.
It's a great set of guidance, but it is at a level that means, as we go back to the terms interpretation and considerations, you have an awful lot of that to do within it. And, modern methods of construction, as they call it, although of course it's not, because of course we were building timber frame buildings in this country, 500 years ago.
For a very long time.
And quite a lot of those are still standing, aren't they, of course? But of course, it does create a different set of challenges, problems.
A unique set of challenges, for sure.
And I think that's quite, it'll take a while for it to catch up. So at the moment, we've just been talking about gaps that are effectively within this relationship between floors and partitions. Is there anywhere else in this conversation that it applies? I mean, for instance, the relationship between the building structure and the external facade. And whenever you mention external, if you talk about cladding, everybody, people either run or you get that sort of blank stare.
They take a sharp intake.
Yeah, external. Are there considerations that have to be taken into account when we're talking about that relationship between the structure and the external facade? Whatever that's made of, by the way, we're not just talking about
really interesting question. I don't know.
Okay.
So
that's not a trick question, by the way. I didn't answer. I didn't ask you because I thought she might know that.
Caught me out. No. So I mean, at my core, I'm all about firestopping. So generally, that's within the building, creating those compartments. So the firestopping that comes into that interacts with external facades tends to be normally edge of slab. So you've got that horizontal movement, joint movement, which I'm sure you're very familiar with from your days in Taiwan.
Yes. Moves a lot apparently in Taiwan.
I can imagine.
Well, because they have, I mean, anywhere around those sort of areas, it's a much bigger consideration.
Yeah. So in terms of how the facade reacts with the slab moving down, very good question. I'm not entirely sure actually.
So we were talking about horizontal penetrations through a vertical wall, its relationship with the ceiling. If you've got stuff going through the slabs, is that also a consideration? If you've got things that are running in through a slab, and that slab is sort of moving can that affect the seal of that particular penetration?
Yeah, naturally. If that, let's say, surface is cast in by a compound type material, that's held very, very firmly in place, isn't it? So if the slab deflects down, it's going to pull it down. So that means somewhere else it's going to add a bit more strain to it. So, I mean, I would like to believe that the service manufacturers have accounted for a degree of movement within their design. But excellent point. Generally, you know, if you've got something like a non-combustible service, they tend to be lagged with some kind of material, so they're not totally cast in, so you do have that degree of movement. With cables, you've got the sheathing, so, you know, internally they can cope with a certain amount of movement, but no, we don't tend to get asked about that kind of consideration.
But it still moves, doesn't it?
For sure, yeah. Common sense, not so common, would say.
Well,
but yeah.
Common sense. Yeah, there you go. I love that phrase, because the phrase actually comes from the use of common law.
Okay.
So you heard of common law.
Yeah. So
common sense is effectively sense that one's sense should be applied to the requirements of common law. There you go. You learn something new every podcast we do here. So we've done horizontal, we've done vertical. A lot of, obviously, over 18 metres takes us into the high-rise, high-risk buildings.
Yeah.
Is there a different level of consideration when you get into into herbs, or is it still the same? Effectively, the principles are the same, the considerations have to be the same.
The principles are the same, the considerations are the same. The amount of movement, I think, the way you quantify that changes slightly. So if you've got the slab deflecting down, the floor above is also going to deal with that extra amount of movement. And when you add multiple floors to that, it accentuates the situation. But yeah, the core principles are the same.
So you talk about accentuate. I mean, I'd call it, amplification.
Yeah,
amplification.
It's a better
So
term.
if you've got a series of these, if you've got a penetration that's running, say, horizontally through a whole series of different walls, and it starts, so further down that sort of chain of reaction, does it get amplified? Does the movement get bigger or the risk get greater?
So again, I like analogies. If you think of an office building, let's say pre-COVID, where it's actually
when
occupied.
When people are in it.
Yeah, exactly.
Yeah.
When
Instead of just empty desks.
went into the office.
I know.
So a really populated building, several floors high. During the day, there is a load to each floor where people are sat at their desk, typing away or doing whatever they do in the office. And then come 5 o'clock, 5:05, they've all gone, because they've gone home, that's the end of their day. So that load across all the floors is then removed. So it's almost like the building relaxes a bit, because it's going to bounce up a bit, isn't it? So yeah, in terms of that, that's certainly a consideration. The use of the building, the life, what did you, the term you used earlier?
Oh.
The life experience.
Lived experience.
Lived experience,
yes.
Thank you. The lived experience of the building. During the day, additional load applied. Out of hours, the load's removed, and it recovers almost.
And is the recovery, and we're getting into sort of tomorrow's world type stuff here, so as people leave, because the 5 o'clock thing, people all leave pretty much at the same time.
Yeah.
Does it immediately sort of
spring load
spring back, or does it sort of move back over a period of time? And I'm so, I live in Worcestershire. I live in a place called Asford, and the other week, Friday ago, Asford was officially the hottest place in Britain.
Congratulations!
I know, it's the only time the village has ever made the news about anything. And it was 34.5 degrees. Or something.
Oh my God!
So I'm assuming does this risk of movement get affected by whether it's plus 34 degrees or minus 10 degrees, and the building is doing this.
So in hot weather, excessive heat, things expand. Liquids become gases, metals sort of expand a little bit. So it is affected by environmental conditions like temperatures, weather, things like that as well. So in colder temperatures, things sort of contract a bit. And going back to, again, my more extreme example, CLT, in hot temperatures, that's going to expand much, much more. So yeah, they do have an impact compared to, let's say, a nice even temperature. So
yes.
in Taiwan, is that like a nice even
No,
throughout the year?
it can get very hot and it can get cold. I think if you go, I mean, I'm trying to think, Singapore is an interesting place.
Yeah.
Because it is generally around the mid-high 30s, high humidity, with a thin cloud layer.
Consistently though, isn't it?
Yeah, and then you have thunderstorms at night. And when I used to go out there, we were working with Brits that live out there, and they said the one thing they missed was seasons.
Yeah.
Because you don't really get seasons in Singapore. It is always around that high humidity, somewhere in the 30s, thunderstorms at night. And I was backwards and forwards for quite a few years, and to be honest with you, it didn't change that much. I
mean, how do they cope as Brits? That's what we do. We complain about the weather
they
at our
just
core.
complain about the humidity and go to one of those sort of made-up English pubs.
Irish
pubs in
abroad.
Singapore, of course. There's probably more Irish pubs in the world than in Ireland, I would imagine, outside of Ireland. Yeah, because I mean that's obviously something that they have to think about when they're designing the building, I'm assuming. And do you get, I mean, as an organisation, do you get an awful lot of engagement from the design community? Do you get, on a daily basis, we have, we're looking to design this in, we need advice?
So we see it as a really positive thing in the industry.
Of course, absolutely positive.
We do have more people engaging with us at the beginning of the building's life, the beginning of the design. So designers, architects, they're coming on to us daily now saying, oh, what about this? How do you approach that? What kind of products do this? We're looking to achieve this. Is this possible? So it's more of a two-way conversation now than it ever has been, which is a move in the right direction. It's really, really good. But yeah, they come on asking about a whole host of different things. Movement is definitely one of them. Environmental conditions, what the products can and can't do. How do they cope with this? Are there any restrictions in terms of amounts of services that they can design in up front? I think as an industry, everyone is moving towards the right aim, and that's to design the perfect building, as you mentioned earlier, not where you're designing as you build, but it's just getting there. And it's nice to see these people engaging with us earlier on, for sure.
No, and I think they need to. And I think, my son studied architecture at Nottingham, and I kept a close eye. Well, I got him to keep a close eye on the curriculum of the 3 years he was doing his part one.
Yeah.
And they only touched on passive fire for about half a day out of 3 years, and it was a quick speed read of approved document B.
Oh, God.
So the following week I gave him some old copies of all the ASFP colour books and a IFE level 3 classroom book, and I said dump all those on his desk, and the lecturer was walking, and then he stopped and started thumbing through all of these, and he said, why have you got all these? And he went, oh, my dad. So and then he had the ASFP website on his laptop, and he went, no, that's my dad, and the colour drained out of this architectural lecturer, and went, oh, right, well, that's really
more than half a day.
Great. Yeah. And he said, we need to study, my dad says we need to study passive fire more.
But you know what? That's the right thing to do.
Yeah, it was.
Get them early.
Yeah, absolutely. Get them early. Get architectural students engaged with this wonderful but sometimes weird world of passive fire in whatever guise or space you end up in, because it is such a major consideration. And we were talking about what we're talking about today is flexible movement.
Yeah.
And people know little enough about passive within the professions, as I call them, without even being asked to talk about the sort of idiosyncrasies of things like this.
Yeah, the things that crop up that sort of change as time goes on, because let's face it, several years ago, no one ever asked about movement.
No.
They didn't really consider it.
No.
So yeah, as the industry evolves.
I think it's brilliant that they're coming. I think it's great that the design and engineering communities are getting engaged with the people that actually understand this, because of course you live it every day. And of course, one hopes that the information that you and us and the other members give them, get put into that Gateway 2 application to, justify the design. Because I think without that, because I think one of the complaints coming out of the building safety regulator is that the applications, certainly in our space, are not detailed enough and not considered enough.
It's bonkers, isn't it?
But the information's out there, isn't it?
Yeah.
You've got an awful lot of...
There's so much out there.
There is.
So the fact that they're not making it through to the packs, it's a bit worrying, isn't it?
Because I don't think because they never used to have to qualify or justify the designs to the extent they do now, because quite often they would leave it blank on the drawings and say passive fire protection here by others.
Yeah.
That would end up with the principal contractor, because they've been awarded the job and been given the bundles, and of course then it would cascade down to the specialist subcontractor, who would then ask to take on, asked to have 10 million PI cover to cover the liability of being the designer of the passive fire protection.
Yeah.
That should have been done much further up the design chain. So I think from that point of view, if they're engaging at a much earlier level, then it means that we should see less of this passive fire protection here by others.
For sure, yeah.
Because it has to have been included within the application.
It's the right way to do things.
It is. It's design, then build, not design as you build. And, we are still... There's an awful lot of legacy to get through of buildings that are now occupied that were designed as you build. Yeah,
and they pose a totally separate challenge, don't they? Certainly for the main contractors and everybody involved, they are.
Yeah.
Yeah.
And we're all happy to help that process. But of course, it is dependent on the people that are auditing those buildings to actually...
And their level of
understand what they're looking at.
And the limitations, especially for as-built environments, yeah.
So, in summing up, what would you say is the 3 most important things in this particular subject matter? So we've talked about early engagement, and I think that's a
given, isn't it?
It's a given.
Education, early engagement, for sure. And it's a theme throughout fire stopping and the passive fire protection industry anyway, as it should be. I would say practicality is another really good theme here. So, you get these numbers, sort of question yourself, is it a practical amount of movement? Is it a practical solution for installation? The practicality is a big question mark at the minute for designers, for installers. And I would also say sort of challenging the existing standards. So that's what we've tried to do.
Sometimes standards try and cover everything and end up covering nothing.
Yeah, and it's difficult, isn't it?
Yeah.
Standards are brilliant. They're a really useful tool. But as you said, they can't cover everything.
No. We've just been dealing with one of those particular scenarios to do with operable fire-resistant elements. The Europeans came up with an XAP that just ended up being completely
excellent,
useless because
that sounds unusual.
It got diluted down, so much to try and please everybody that it ended up just not.
It was not worth the paper it was written on.
Functionally, it didn't offer the solutions that most people needed from it. Everybody got a bit, but nobody got a whole, if that makes sense. And I think there's a whole debate around our relationship with Europe. Of course, we left the common market, but we haven't left European standards,
certainly,
which creates a whole series of challenges. And what was so that was the first one. The second one, what do you think the second one should be? So the first one is be realistic about what you're saying. If you're not sure, don't make it up.
Oh God, no!
Don't write down 200 plus or minus 200 mil, because you think if I write down a big number, it covers everything.
Exactly. So education, early engagement, practicality. Make sure it's reasonable, and then, like I said, challenge the real world. Experiences, what actually happens and how we adapt. So standards take a long time to update. Naturally, they're very complex things. So how do we challenge that to offer real world solutions?